Welcome to SpeedyPodz episode 22.
And happy January 2026. What a start to the year. It feels like news is just exploding everywhere.
It really is. The theme, I think, has to be shattering limits. We're seeing people break context windows, break the need for human data.
While at the exact same time, big tech is getting dangerously close to breaking the actual power grid.
That's the real tension here, isn't it? On one hand, you have software getting just radically more efficient.
And on the other, the physical world, the chips, the electricity, it's all groaning under the weight of this demand.
Okay, so let's start with the wins, the software side. MIT seems to have basically solved the memory problem.
Right. This paper on recursive language models, or RLMs.
It's all about this problem they call context rot.
Yeah. We have these models now with these huge million-token context windows, but if you actually try to fill them up, the model just gets confused. The performance tanks.
So what MIT did was, it's clever. They just stopped trying to shove 10 million tokens into the neural network.
Exactly. They built this sort of scaffold environment around it. It's called Ripple.
So your huge prompt just lives in a text file, and the model uses Python tools to search it.
It searches it, yeah. And if it finds a section that looks interesting, it recursively calls itself to, dig deeper just on that one part.
So it's navigating, not just compressing or summarizing everything at once.
That's the word, navigating.
Yeah.
And the result is basically infinite context without that degradation we were talking about.
And get this, it's cheaper.
Yeah.
Significantly cheaper, because you're not loading the entire 10 million tokens every single time.
What were the numbers? Something like 99 cents for a huge task.
Yeah, versus over $1.50 for a comparable model, like a GPT-5 mini. It's a huge difference.
It just goes to show the scaffolding around the model is becoming as important as the model itself.
Speaking of smarter models, Meta just dropped something that sounds, frankly, a little terrifying: Dr. Zero.
Yeah, it sounds like a Bond villain. But the concept is huge. It's an AI trained with literally zero human data.
Zero. So no internet scrapes, no books, nothing.
Nothing. It totally challenges this core idea from the past few years that more human data always means a better AI.
So how does it learn anything?
It's basically two AIs playing a game. One of them generates really hard but solvable questions, like a complex math problem.
Okay.
And the other one has to try and answer it. And they grade each other and get better over time.
And it actually works.
It works incredibly well. For factual and math tasks, it's beating models trained on millions of human examples by up to 22%.
That's wild. So what's the catch?
The catch is personality. It's not great for creative writing or, having a conversation. But for raw logic and facts, it suggests we might not need to scrape the whole internet after all.
So the software is getting leaner and smarter. Meanwhile, the hardware side is just a complete war zone.
Oh yeah. CES just happened, and the battle lines are clear. It's Nvidia versus AMD, as always.
Jensen Huang gets on stage and announces the Vera Rubin platform. He's making it so clear they're not just a GPU company anymore.
No, he called it a full AI factory stack. It's an entire system designed specifically for these massive 10 million token contexts we were just talking about.
At AMD, Lisa Su's countermove was to position them as the sensible enterprise choice.
Right. Their new chips, the MI455 and others, they're for standard business infrastructure. They're basically saying, let Nvidia chase the moonshots, we'll power your actual company.
But none of it matters. None of it runs with that power. And that's the real story right now.
The power crunch of 2026, it's here. Microsoft just announced a major partnership with MISO, the grid operator for the entire Midwest.
Data centers are now officially grid stakeholders. I love that corporate speak.
It means they're part of the problem. You're hearing, bring your own power, become the new standard.
And some regional operators are even saying that data centers might have to disconnect during peak hours.
Can you imagine a multi-trillion-dollar AI cluster having to shut down because it's a hot day and everyone's running their AC? That's the wall we're hitting.
It explains all the consolidation we're seeing, too. Meta paying, what, $2 or $3 billion for a company called Manus?
Yeah, just for agentic harness. Basically, a tool to make sure AI agents actually finish the tasks you give them at scale.
And Cursor, the AI code editor, bought Graphite, a code review platform.
They want to own the whole pipeline.
Yeah.
From the first line of code to shipping the product. Vibe coding becomes an enterprise software factory.
Even OpenAI basically threw their hands up and said prompt injection is probably unsolvable.
Right. So security is now about seatbelts, not locks. It's about having processes and logs, not a perfect impenetrable door.
Okay, let's try to pull this all together. On one side, we have these immense physical constraints, power, chips, infrastructure. It's all squeezing the industry.
And at the very same time, you have these software breakthroughs like MIT's RLMs and Meta's Dr. Zero, showing us how to do so much more with less. Less data, less compute per task.
It's a real paradox. So here's the final thought I'm left with. If MIT's work gives us infinite memory,
And Dr. Zero proves you don't need our data to learn facts.
are we watching the end of the big data era? Are we about to enter an age of, I don't know, self-sustaining infinite memory agents?
I think we might be, assuming, of course, that we can keep the lights on long enough to run them.
We'll be watching The Grid. Thanks for listening.